So the Learn tool by WRI Nickley, or Land Emissions and Removals Navigator tool, is an application for communities to calculate the net greenhouse gas emissions over a time period from land use and land cover change within their communities. So that's a conversion of forest land to non-forest, or planting more trees, removing trees, that type of thing. So the application is actually really straightforward, very simple, very streamlined, and we're using just a few data layers in it to go into this workflow. The first, we have the NLCD, so the National Land Cover Database. That's used as our input file or input source for land use changes. We have U.S. municipalities as inputs. We have a forest region layer. This is used for calculating some of the carbon factors because different forests and different areas have different carbon factors. We also have the NLCD 30-meter tree canopy data for 2011 and 2016. This is used for calculating emissions from trees outside of forests. We recently added 1-meter high-resolution tree canopy data from the Chesapeake Bay program for the Chesapeake Bay watershed as well. And then the other data set that goes into this analysis is a forest disturbance layer put together by WRI, where they identified forest disturbances from insects, fire, and other disturbances. And that goes into the analysis as well. And you can see I think this is a beetle in New Jersey that really decimated southern Jersey for a bit. All right. So let's run through the workflow then for you. So like I said, very streamlined, simple workflow. The first thing I'm going to do is select my area for my inventory, and I can select from our county file or upload a shapefile. I'm going to select Loudoun County in Virginia, which has a lot of suburban sprawl in the DC area here. So I've selected my county. I press next. I configure my inventory period, and I'm going to do 2013 to 2016, and that'll allow me to use this new high-resolution tree canopy data set from the Chesapeake in the analysis. If I were not in the Chesapeake, this option would not be available, but we do have plans for bringing in more high-resolution data. All right, I'm going to press next. Two things are going to happen right now. One, I'm firing off a geoprocessing service that's going to do the analysis. And two, there's a front-end raster function. Both are doing kind of related things. So the way the analysis works is I take my NLCD year 1, NLCD year 2, create a pixel-by-pixel change matrix between the two of them. I can then compare that to the age and forest type map that we have in the background that tells you how old different forest types are and used for looking at the carbon factors, looks at the tree canopy data, looks at the disturbance data, brings all of that together to run the analysis. And then I just need to select one more input for some carbon factors for trees outside of forest, and we have my inventory. The other thing that was happening was on the front end, we were using ArcGIS image server and front-end raster functions to actually compute that same pixel-by-pixel change matrix, but slightly simplified. So if I go back to my map layers, we can now see our land cover change layer. So we identify settlement, remaining settlement, and other classes that stayed the same. So the key items to look at are changed to forest and changed from forest. So we can see there's some development going on here where things were converted from forest, but we actually do see a little bit of change to forest as well. And that's often with grassland and cropland converting back to forest. All right, but anyway, we completed our analysis. So we can see the total net greenhouse gas emissions. We can see the emission and removal factors that were used to calculate this. We also have another tool for harvested wood products. A user is able to download a spreadsheet. And so if in your community there is harvesting that goes into wood products, that actually doesn't count towards a carbon balance the same way, because if you chop down a tree and turn it into furniture, the furniture is actually still storing your carbon differently than if you. So that calculator goes in there. And so if I would input the results from that calculator, and then that counts towards against the overall balance. All right, so I can download the data in two formats. So if I view the full report, this is going to generate a PDF report customized with our analysis. And I can now download that and open that up. So here's our report. Here's our table. You can see key findings. We've got some nice charts and graphs and maps that show, what the conversion was, where the gain in forest was, so grassland to forest. We see forest to grassland, forest to settlement as the loss of forest, and then seeing trees outside of forest and what categories those are in as well. We can see our pixel by pixel change matrix, so you can see what classes changed. If you follow down this center line, that's what stayed the same. And then a simplified version rolling it up to 6 classes. And then we also allow the user to download that data as a spreadsheet and view some more of that information here. So there's that change matrix again, the emission removal factor, emission removal items, and the carbon factors as well. And this analysis is a Forest Service methodology. So it does follow the methods promoted by the Forest Service, and we have all of our guidelines, data, methods, everything available as resources here. And so if we look at the documentation here, you can see this method, and this is going through peer review to be published as well. And so that is the Learn tool. It's a really simple, streamlined workflow for calculating net greenhouse gas emissions from land use land cover change. What I love about this app is it took the history of it is that this started as a spreadsheet workflow. WRI engaged with some communities and the Forest Service to develop this workflow as an offline workflow, then a desktop GIS to spreadsheet, and then we converted that spreadsheet workflow into a really seamless, easy-to-use geoprocessing tool that takes 3 to 5 minutes to run. But the math and the science behind all of this is really complex. The user interface is very, very straightforward.